It has started, right? Recording.
Yes.
Okay, perfect. So once you have your HPC account, you will need to sign in. You need to log into HPC, and for that, I have given you guys like these commands. Here is how you sign in. Whatever commands I'm gonna use here, I'm gonna write them down here, so later on you can just see and do things. So if you wanna sign in, this is what you do. You use SSH, and if you write this -x, it will help you open up some GUIs on your system. And then, of course, your user ID at hpc.iitt.in, ac.in. And then you enter your password. I guess mine is, okay, perfect. So we are in. Can you see it? Anyone?
Okay, so I'll show you on Windows how to do that. Just a minute, Krishna. Let me share my screen. Okay. My screen visible?
Yes.
Yeah, just a minute. So you can see here Mova Extreme software is there. It's pretty easy to install. Just click on it.
Yeah, I mean, install this particular software for Windows. This will help you connect with HPC.
Okay, so for a new session, you just go to session and click on it, and then SSH, and for remote host, hpc.iittd.ac.in, and then specify username. So whatever Kerberos ID you have, just type it, and then OK. So we have logged here. Okay, you can see few things like ls. I have few things here. So ls is used for like looking for whatever directories and folders you have. So I am having these two folders on my home directory. Okay, HPC workshop and Scratch. I think Krishna will take the next thing. You can share, Krishna, your screen.
All right, so yeah, that is how you log in into HPC using a Windows device. I'm gonna share my screen. Stop sharing. It's pretty interesting. I cannot share my screen from here.
No, I have unshared. You can share it now.
All right, I guess I'm gonna have to stick to Mac now.
So how many of you are using Mac here? MacBook. Hello, am I audible?
Sir.
Yes,
Sanoj, you are using Mac, and Toki.
No, sir. No, sir. I'm using Microsoft Windows.
Yeah,
no, Windows,
I'm
right?
also using Windows. Yeah.
Windows. Okay. So for Mac people, it will be like whatever Krishna is like showing will be helpful for you, like. And it's the same, like terminal is same.
Yeah, terminal is the same, irrespective of your operating system.
Yeah.
I mean, if you're using MoveX term on Windows.
Exactly. So mobile extreme, just the logging thing, you have to take care of that, and then if you are into the terminal, then everything is same. So yeah, Krishna, go ahead.
Give me a sec. I'm gonna sign in with this Microsoft
Okay,
operating
fine.
system.
Okay.
Yes. Can you see my screen?
Yeah.
Perfect. I'm gonna run mobile store. New terminal. I'm gonna sign in. Log in into HPC. SSH with -x. Okay, and then I'm gonna enter my password to sign in. Oops, it's incorrect. Whoa. Oh yeah, there's a mistake. If you don't write HPC here, they will expel you, even if your password is correct. There we go, we are in. So, like Neeraj said, ls is what you use to figure out what are the files in this particular directory, and your location where you are right now. You can check with pwd, which is for present working directory. And so we have seen like how you can sign in. We see how you can list your files in current directory. You can check what is your present working directory. If you wanna know, let me see. I'm gonna go to documents. I'm gonna create a new directory, mk make directory. This is what you would use.
So
mkdir.
Krishna, just a minute. So cd command we use for changing directory.
Yes.
Okay. So
Yeah.
that's why it's cd. Okay. So if you want to go to some other directory, cd. And there are also like other options available with cd. Like if you'll go with cd .. then it will take you to the previous directory. Okay. That
Yes.
Krishna will show you in a while. And yeah, Krishna, go ahead. Just show the cd use of cd command.
All right. So you see that I was here in root directory, and right now I am in documents directory. So if I say cd .. that will take me up by 1. You can see now I am at root directory back again. So
No.
the cd is for basically
cd,
change
yeah.
directory.
Yeah.
So I'm gonna go into documents directory, and this is where I'm gonna make a directory called, directory is like a folder in Windows. So I'm gonna make a directory, say test. And if I listen again, you see I have test. So this L is a shortcut actually that I have created. I'll like later on we can show how you can do that too. But that L actually refers to ls-ltrh. All these flags you will learn later probably. Ls is simply to list the files, and these flags, all of these. This one is for long, L. T I think is for time, and R I'm not sure, but H is for human readable format of this data. So for example, if you have some file, say 5 GB, and if you don't write H here, it will give you in kilobytes or probably bytes, and that is not readable. So you can see right now it says in 4.0 kilobytes, so that is readable. Let me show you. Look at this now. It says 4096. If you have a file really large, there are going to be so many numbers, and pretty weird numbers, and that are not necessarily easy. So that H basically helps you print all these things, the size in human readable format. Anyways, moving on. So I've created this new directory called test. Let's change the directory and go inside this new directory. And right now you can see I have nothing in this directory. So I'm gonna create maybe a file. How do I create a file? I can say touch file1.txt maybe. This is how you would create a file. And let us see again. Now we have that file here, you can see. So once you have created the file, how do you edit it? That is one thing. There are so many editors that you can choose. There is Nano. This is one editor. And also, say you know that you have one file in this directory, and this is the name, and you have already entered the first two characters. You want to fill it. You don't want to enter everything. You can use tab, and that will try to match the strings and then fill for you. Anyhow, coming back to the editor, how do we edit this file? How do we enter some text in it? There are so many ways. One of them is Nano. You say Nano and then the file. Now, Nano will open up your file where you can make changes. And probably you can see here, this one is for, I think, Control O. If you say Control O, this file will be written. Okay. So I'm going to say Control O. And it's asking me, do you want to write? Here I have an option to change the file name. I'm like, okay, let me write. I'm gonna enter. And now this file has been written. Now what do I do? I wrote some text. I saved the file. Now I need to exit. And for that, I have this option, Control X. I'm gonna say Control X. Here, now I am out. Now, I wanna make sure, I wanna see whatever I wrote in the file, is there or not? I mean, this is like, you want to see what is in the file. You can use this particular thing, the command cat, and then give it file, whatever file you want to see, the content of the file. And it will show you whatever is in that file, okay? There is another command called tail. This will come in really handy when you have a file that has millions of lines. You don't want to, just print all the lines here in
like
the
5
terminal,
lines
millions
from
of them.
the end here. Yeah.
Yes. So this tail will help you print a specific number of lines in the end or in the middle, depending upon what flags you give it. So for example, I'm going to just say flag file, sorry, tail file. So right now the file has only 2 lines, so they are basically shown here, but this will help you later. So see, if you want to say, I want only one line, one last line, you can give it a flag and followed by the number of lines that you want. Okay. So yeah, these are some commands. Let's move on to the next. Now, I made a blunder. I don't want this file to be here. I made some mistakes and I want to remove it. How do I do that? I say rm for remove and then the file name. That will remove the file. Now let's check again. There you go. We don't have that file anymore.
Yeah.
Make sure that whenever you're removing a file or directory, make sure that is what you want, because once you delete it, there is no going back in Linux. There is no going back. It trusts, the Linux trusts that user knows what he is doing. There is no recycle bin here.
And so Krishna has shown you to remove a file. So you can use the same command to remove a directory, but
Yes.
extra thing you have to add there, that -r and then the folder name. Okay. So
Like
can
for
you show
example,
Krishna? Yeah.
I'm gonna create one directory called D1. I'm gonna create, D1, D2, let's just do D1, D2, D3, and say D4. Okay, so I have created these 4 directories, 4 folders, and I don't like any of them. I want to just remove all of them. It's just too much clutter for me. What I'm going to do is I'm going to say rm -r, and then I'm going to say d. Notice these directories have one thing common. They start with d, and the second character is basically a numeric, right? So this r flag in remove command tells Linux to remove recursively. R for recursive, basically. This will remove recursively all the things that come. Now, I know that I want to remove all of them. So I can say D, and I cannot say it's D1 and then D2 or whatever. I can simply say D star. This star is really helpful in Linux. It means that, okay, the first character has to be D, the second character can be anything. Star basically fills in all the possibilities for Linux. This is one way. If I hit enter right now, all the folders will be deleted. There is no going back. Another way, to do that is, yeah, let me just remove all of them. See, I have no folders anymore. So what I'm going to do now is touch F1. I'm going to create few files. Say I have these 3 files. You can see I have 3 files, F1, F2, and F3. What I want to do is I want to remove all the files now. How do I do that? Again, rm rf star. There you go. That was removed basically. And now, say I create a file. I'm going to create T1 and T2, 2 folders. Oops. And I'm going to create a file, say F1, right here. So you see, I have created these 2 directories and I've created a file. I made a mistake. I did not want to create this file right here. I wanted to create this file actually in this particular folder, T1. So do I delete this file and then go back in T1 folder and then create another file, F1? Well, that is one possibility. Another possibility is you can simply move this file from here to T1 or T2, wherever you want. So there are 2 ways, right? You can either move, that will remove this file from here and put it inside this directory, or you can copy, that will leave the file here as well as make a copy of that file within this directory. So say I want to move it, I don't want it here. I can say move what? You want to move F1. Now, where do you want to move it? Say T1, this is where I want to move it. Right now, you can simply give the directory name, but say if you want to move this file somewhere else, in that case, the location has to be absolute. Here you have to enter an absolute path. We'll see what that means. Let's check now. Now you can see I don't have that file. The file must be in T1 directory. Like I said, F1. So that's basically copy, move, yeah, present working directory, ls, remove, all those things. I guess these are the most used commands that you will need basically. I'm gonna go back. Go back one more probably. No, leave it. This just be here. Now, I'm gonna create a file, say Python script. Okay, I'm gonna write a Python script right now. Let's see what we have. I don't want these ones. I'm gonna remove them. T star. And I'm gonna create a file called f.py. Okay, I have this file now. Now, I showed you how you can edit the file with Nano.
Yeah, gedit you use, that will be more
Yes.
handy.
There is another tool called vi p.py. This one is again a same terminal-based editor. If you like that, go ahead. If you don't, gedit is something that you will love probably. Gedit and then the file name. And it's not just that you have to give just one file name. If you have multiple files, you can just give multiple files, f2.py, f3.py, or not even that. You can simply say f. If you have, let me create f1.py, f2.py, and f3.py. And I want to open all of them at once. I don't want to open them separately. I can say f*star.py or simply f star because f is common in all of them, and then star basically fills all the characters afterwards. Let's see. And you can see that it opened a GUI for you with all the files open there so that you can edit all of them at once. Anyhow, I'm just gonna take a sample Python script. Oops. Let's just say, yeah, sure. Yeah, and then print that. So we just say color, right? Okay, I have edited this file and I changed my mind. I don't want to edit all of these. I'm just gonna edit this one and save. That's it. So I've saved with Control S, or there is a button, and exit this one. I have all the files. Let me check if I have contents in my file. Oops, looks like I do have. Now you want to run this Python script. How do you run it? Notice, like, note that you have just logged into HPC. Okay, you're there in your HPC. All the files that you had in your HPC, you have access to them. But right now you have nothing to run. You don't have, yeah, shell script for sure you can run, but you cannot run Python. You cannot run, CFD codes. You cannot run whatever. I mean, any kind of code you cannot run right now. MATLAB code, for example. For that, you have to have library. You have to have interpreter of all those things. So say I want to run Python script. What do I need for that? I need probably Python, something that can interpret Python. So you have to load that interpreter or that library. So how do you know, like, how do you load that? These concepts are summed up in something called module in HPC. Module is basically a software or interpreter, some sort of library basically that will help you run your course. Okay, so here is one way you can say module. Do we say list, module list, or module avail? I think module avail.
Module
This will
avail.
list
Yeah.
down. This will list down all the modules that HPC has to offer, that HPC has. Let me run it. It's going to take a while because there are so many. It's going to list all of them in my terminal.
I think you write Python also, so that whatever is related to Python
Yeah.
is used.
You can see that there are so many, these packages, softwares, and all of them are listed here. So this is one way you can simply, look for it, and then you can see, okay, here it is. One Python package is this one. I can simply load this one if I want. If I want to load this one, I can simply, copy this one and then say module load and then paste it. So this is how you load that software or interpreter. You say module load and then its address. This is the address of that particular Python package. If you want something else, you have to give that address basically and hit enter. That's it. Now your current session has access to this library. Okay, so whatever this library can do, you can do right now, right here in this terminal. If you open up a new terminal here, again log into HPC, you don't have access to that particular module because that module exists in this session. That's it. Once the session ends, that's it. You have to reload all those modules. Anyhow, once the module is loaded, and if you want to make sure that you have loaded it, this is what you do. You say module list. It will list all the modules that you have loaded in your current session. Okay. Say, for example, that by mistake you loaded this module, but rather you wanted to load something else. I don't know, maybe like this one. How do you do that? Because you don't want to load two different interpreters or two different conflicting libraries, right? You have to remove first one. In some cases, you might need that. In that case, you can simply say module purge. That will unload everything. That will unload all the libraries, interpreter, software, everything. You can go ahead and say module load and done. Now you have Python. So say, for example, right now I want to run this particular Python script. How do I do that? Okay, I need an executable. I need, a handle to this library. I need a handle to this library, right? How do I'm not just going to say f1.py and run it because that's not going to run. I have to give this file to some library that can, run it, that can read and run it. So since I have loaded Python, I'm guessing that its handle would be something like Python. So I'm going to just write pyt or simply py and then hit tab twice. When I hit tab twice, it fills in for me. That basically tells me that maybe this is the handle. So I'm just going to hit enter space and see if that is the handle and try running it. Oops, it ran. So you can see this is the handle Python that is provided by this particular library. So I use that handle and give it the file that needs to be run, interpreted. And this file basically, I think in initializes a variable and then prints. So yeah, that's what it did. So now you know how you can run your Python script here. I'm gonna unload this Python module. And now if you wanna say, we don't have any module loaded right now. So okay, the same way, you can load any module and then basically run using that module's handle, okay? I wanna give you one tip. Module list, you know that it's gonna give you a lot of content, all these things. What I did in my system, I copy pasted all this module basically. So say I have copied all of them. Dude. Let me show you how, yeah, module analyst, module available. So this is what I have. I'm just gonna copy some of them. Copy, and then I'm gonna create a file, text file in my current system. And paste all those modules here. So when I log into HPC next time, I don't wanna again module avail. I don't wanna run this command again because I'm not gonna remember all those modules, their directories where they are. So I'm not gonna run this again. Next time when I log in and I wanna load some module related to Python, I'm just gonna go back to this particular file that I have created in my system. I'm gonna search for all the Python, modules that are available in HPC, and look, yeah. So I'm gonna search for that, and I'm gonna find it, and I'm gonna just copy paste right from here. I don't have to again type module avail because that takes time. So that is a tip that you can use later to save yourself some time. So that's basically what module is and how you can load it, how you can purge it, how you can run your commands. Also, I'm gonna move on to next, which is what is login node and what is compute node. So when you log in, this is the node that you get. Right now, I am in login node number 3. There are 4 login nodes in HPC. Say you don't like this login node, or for some reason you have to switch to other login node. What you can do is you can say SSH login 001. That is the ID of login node 1. Oops. What is wrong? Okay, so it's actually 01, not 001. So now you can see that how you can change or run between the nodes. So that's basically right now you are at a login node, and this will allow you to do simple things like copying files from one directory to another, creating a directory, moving things, very simple things. Or even if you want to run a job, say that runs within 1 minute, not more than that. If you know that this file is going to take more than 1 minute, you better ask for a compute node specifically and then run your job. If you're running in login node more than 1 minute or so, the CPU uses will spike, and HPC will detect that, and they will ban your account for next 48 hours, just to say, but that is not exactly that. They're gonna ban you for like 15 days or 20 days. And then you have to mail your professor, and then she has to mail them, and that is how you're gonna get your account back. So never, before submitting a job, always check if you are at login node or compute node.
Yeah, so make sure about these things now. Otherwise, you will be blocked for like 15 days. So never run never run your simulations or something on login node. Even your script file like for C or Python, because maybe what if it will run for more than 1 minute, then you will be in trouble. Okay, so take care of these things, and whatever the commands are there, I think in video like recording, you will be able to practice it later. So these are very basic commands that we will be keep on using all the time. Okay, and I think this is pretty much for the simulations and all. Later on, what we are going to look into is how to get the compute node. So how to get the
Yeah.
resources from HPC where we can run our simulation. So Krishna, go ahead.
So yeah, right now you can see that this is the account, and this is where I am, login node number 1. And now I want to request HPC to give me some compute node where I can run my code without being blocked. How do you do that? There are two ways. There is PBS script that you can write and submit your jobs. Another way is interactive session. You can ask for an interactive session. First, I'm going to show you interactive session, and then we'll see what is PBS and how you can submit with PBS. So in order to ask for the resource, compute resource, the command starts with q sub and then -i for interactive job. And you make sure you include X because this will help you with GUI. If you don't have this X, then it will not open GUI for you. For example, you saw that we opened up an editor, gedit, using that gedit thing. So yeah, include this -X. This helps a lot. And then these are some flags. And select one. That tells HPC that I need one node. Then colon and CPUs equal to, say, I want 2 of them. So that tells now that, okay, I need 2 CPUs in one node. If you want some GPU also that you can request, you can simply say n GPUs equal to 1. Say I need 1 GPU. GPUs are pretty expensive. First of all, you cannot just randomly ask for 14 or 16 of them. So make sure you know how much computation you need, and accordingly you request for the number of GPUs, CPUs, and nodes. And just notice that it's not NCPU, rather it's NCPUs with an S. Okay, let's go ahead. Now comes the kind of architecture that we want. At IIT Delhi HPC, they have Haswell, they have Skylake, they have Ice Lake. I think these are the 3 different architectures that they have. So this is kind of like, let me tell you, one is Haswell. You can request Haswell kind of machine, which is pretty slow actually, as far as I know, compared to Skylake. This is more recent. And so this is one machine. The other one was Haswell, of course. And the third, the newest one that HPC has is Ice Lake. This is another machine that HPC has. So let us just say I want Haswell. I want to stay in the middle in terms of the speed. Okay, so I'm going to just say CentOS equal to Haswell. That's it. So this -L starts your the kind of resource you want, compute resource you want. And this is where it ends. Now you need to tell for how long you want this resource. You can say that by saying, okay, -L starts another kind of information. So wall time is what you need. You need to mention wall time. That tells HPC that, okay, for this many hours or time, seconds or minutes, you want HPC compute resource. So I want for 15 minutes, okay? Or maybe let's just say 30 minutes I want. Notice that these 2 numbers are for hours, separated by a column, and then minutes, and then seconds. So accordingly, you should enter the numbers. And then comes the project with which your account is associated or you have access to, because HPC is not going to give you a compute resource if you don't have money in your account, in your project. Okay, so for right now, I have this particular project. And even if you know somebody's project number or name, you cannot really use it because that particular supervisor has to give access to your HPC account within that project. If she has not given or he has not given, you access, then there is no point knowing that project name. Anyhow, so yeah, that's pretty much it.
Yeah, but
This is
you
how
can
you
use
would.
like departmental
Yes.
facility. Yeah. And for that, department we really don't have that much of budget, and we can, like, we will also talk about the nodes, like, sorry, queues. So Krishna will explain about
Different
these
kind of
things
tools.
later on. Yeah. And one question was from Akshay Raj, what is the maximum we can request? So that depends on the architecture. Okay. So as Krishna showed that CentOS equal to Skylake as well. So these are having some specific amount of CPUs that you can ask for. Okay. So we will show you about these things later on.
Let me tell you, the number of Haswell CPUs that they have is 257 in HPC, and I think per node there is. Let me see.
So it's
Yeah,
like you have
I think
yeah. Go ahead.
maximum 12 physical cores you can get in Haswell,
Hmm.
which can be translated to 24 cores virtually speaking, because each core behaves as two. In Skylake, you can get maximum 20 cores physically, but of course you can access up to 40, but that is physically 20 cores. That is what they have. And yeah, that's basically it. Also, Haswell architecture has 64 GB of RAM, while Skylake has 96. And let me tell you, for most of the jobs that we are going to do, 64 GB RAM is going to be enough.
And also, like, you guys can make combination of, like, this nodes, so NCPUs and like NCPUs and number of what they say,
GPUs?
yeah, GPUs, make combination of that also, or number of nodes also, like select equal to
Yeah.
1. So you can select equal to 2, and then if you want to run on like 48 CPUs, okay, then you have to select two nodes, and then there in NCPUs you specify 24. Okay, so then you will get two nodes, 24 of each, right?
Yeah, I mean, say for instance, you know that um, Skylake can maximum offer you 40 cores, and but 40 cores is not enough for you. You need 80 cores, or maybe 56 or 64 cores. So, and remember that here you can only specify one architecture: Haswell, Skylake, or Ice Lake. Now, within that architecture, you have to manage the number of nodes and CPUs and GPUs. So within Haswell, I know that in Haswell there are maximum 24 cores in a node. Okay, and but 24 cores is not enough for me. I need 48 cores. What can I do? I can say number of CPUs equal to 24 here, and I can say two nodes. That will give me 48 cores basically, in separated in those two nodes basically. So that is how you can get more number of cores, as many cores basically as you want. Of course, limited by the maximum number of cores available at HPC. So yeah, that is how you can mix and match node and number of CPUs. So let's just, let me ask for this particular request. There is something wrong. It says Q sub version. All right, I'm just gonna exit and see if that is the problem. Oops. SSH XY, I'm gonna try this time. CHA 218339. Okay, and then Q sub interactive with GPU. I want L select one and CPUs say two and CPU say one, and CentOS. Yeah, CentOS, because that is the operating system that HPC runs on as well. Wall time 00 and 30 minutes and project. Perfect. So did you say that last time when I was submitting with the same command, it was not, because it said queue sub display not set. I suspect that was because of the flags that I used. Maybe that I did not use, I think I used X, but using this Y particularly helps. I don't know like how that depends, but sometimes with my Linux at least, only X flag is enough, but I don't know. Here in MoveXterm, I did need Y. So once I logged in again with this particular flag, with Y along with X, I could submit the job, and you see I have access to this particular node now. K-has, which basically tells you that it's a Haswell architecture, 043. This is the node number. I'm not sure if it said, but you have total 257 nodes in Haswell architecture. Right now, I am in 43rd. And whenever you land into a compute node, this is the kind of directory you will be in. Let me see. You can always go to, you just change directory to your root place, which is given by this tilde. No matter where you are, you can always say cd tilde. This will take you to your root directory. Okay. All right. So here we are, and now I know that I am at compute node. I have access to this particular compute node for some time. I wanna now here I can submit my compute intensive job. I can submit, and that job will keep running. If the job finishes before 30 minutes, all well and good. If it does not, HPC will come in between and terminate your job. So yeah, that is how you get. Let me show you this particular thing called Turbo VNC, what that is. Say for instance, you do not want to work with terminal, you just want an interface of HPC. That you can do. You need to load a module called Turbo VNC. Let me search for that particular module. Module -I keyword. This is how you can search for specific. So what I'm trying to do is I want to search for a module that has this particular character, this string in that particular module names. So you say module -I keyword, and then you give the keyword basically. Let me see if that works. Okay, it's gonna go and search for me all the modules that have this particular keyword. Okay, it looks like we have some results. I know that this is the one that I want to load. So I'm just going to copy that module and load it here. Enter. And now I have this Turbo VNC. You need this particular module if you want to have an interface of HPC, what HPC would look like if it was a computer. So, okay, I have this particular module loaded. Okay, yeah, this particular module gives you two commands. One of them is VNC, I think password probably, PA, yeah, this one. So first of all, I'm gonna create a particular password. So this is what I want. This is my objective. I want to see HPC as if it was a computer. For that, I need to use this particular module, which will allow you to have a GUI of your HPC. And right now I'm setting up a password so that no one else has access to this particular GUI other than me. So I run this particular command and I'm gonna set a password. and again verify. Oops, it did not match. Okay, I'm just gonna say no that to that. Okay, I have set up the password. Now I'm gonna launch the GUI with VNC server. You run this particular command and it's gonna give you one ID. Here, this is the ID that you need, k-has043:1. Now you can go to another terminal. You have to go to another terminal, SSH with XY USERID at spc.iidt.ac.in. Okay, enter the password. Okay, I am in. Now, what I want is here, I have started up the server at this particular place. I can go to this particular another terminal in HPC, and I can run this command VNC viewer. Now, this particular command here in second terminal, you don't need to load that particular module. VNC viewer is always available to you. And when I hit enter, it is going to ask me for that particular ID. I know that it is k-has43:1. So I'm just gonna enter that ID, k-has43:1. Okay, I'm gonna do that and say enter. Unable to connect. All right, I'm gonna try that again.
No, it's 2. It has changed. Try from 2. See?
Oh, all right. Okay, let me try 2. Enter. And now it's gonna ask for the password. Remember the password that I set with VNC pass WT? That is the password that I'm gonna need here. And that is why you need to set up a password so that nobody else has access to it. And right now what you see is HPC itself. You can see that it is running on CentOS version 7, and this is basically your HPC. Here you have access to everything. It is a GUI, you don't have to move here and there. You can basically, So this is my account in HPC. I can move around however I want now. I don't need CD, I don't need LS, I don't need CP, move, all those things. I can simply do with GUI. Anyhow, once you are here, you will still need terminal for some things. You can simply open up terminal by right clicking here. It will give you option, or you can also do right from here. And here you can see it's like your own computer,
It's on compute node, Akshay, because we have taken first the resource and then used it.
Yes, so that is what I mentioned. When you're running a job, you should not run it on a local login node. Okay, and you do need one GPU at least so that this GUI thing is supported. Notice that this whole thing is still running on k-has43. As you can see, the moment I opened up this terminal, it actually opens up in this particular node. That tells me that, okay, this is the node that I'm running on. This is the node where this whole GUI is being processed. All right, and let me see what is next up in the list. We have requested for the resource. Yeah, one thing that I want to tell you is, say for example, right now I'm running some Python script. Okay, I have loaded the module and I'm running some Python script f1.py. And that script I know will take, I don't know, a day, for example. I can start running that script and it will keep running as long as I have this particular GUI and terminal open. What if I close this particular terminal? What will happen? The job will finish, the job will end because the terminal doesn't exist from which you launched the job. So whenever you ask for an interactive session, whenever you ask for compute resource using interactive method, which what we are doing right now, the jobs that you run in a terminal, they will end the moment you end the terminal. Okay, there's a trick to that. You can use something called a screen. Screen is again another command provided by Linux. Screen -s for a start. This will start a screen for you. Say, for example, I want to start a screen, some project named MC, Monte Carlo for it stands for Monte Carlo. Screen -s MC. Now this will, what it will do is it will create a terminal called MC for you, which will never die, unless you kill it. Right now, I am in that particular terminal which I just created. And here I can launch whatever process I want, and that will keep running as long as your compute node is active. It doesn't matter you kill the terminal or you leave it open, it doesn't matter. So basically, screen is a really handy tool that you will need it. And let me tell you how do you exit out of that screen. Right now you are here and you know that your actually screen terminal is active. You want to go out. For that, you say Control A for selecting everything, and then Control D for detaching terminal. So see, when I said Control A and then D, it detaches from that terminal. Let me tell you, that terminal is still active. I can close this particular terminal and I can open back again another terminal. And if I say screen ls, it will tell me that this particular screen is still active. That means if I launched a process from that terminal, that must be active. That has to be running, even though your GUI is all done and this terminal is all down. And if you wanna again reattach to that particular screen, I think you can just say screen R and the ID of that screen, which is 719.mc. There you go. You're back into that particular screen. Let me show you a few things. Maybe PWD, Control A and D, back to normal terminal. I'm gonna go back, reattach my screen terminal, and you see wherever I left off, exactly there you will land basically. That's it. So when you are asking for interactive session, a screen terminal will come really handy. It will help you a lot. Now we'll go to PBS scripts. This is again the HPC running right now. I'm just gonna leave it running. We're gonna use it, or maybe I can simply kill it, end it. I have ended that. I'm just gonna purge from here. Perfect. And my job is done in the compute node. All the processes are over, for example. Before that, let me show you this. Say right now I am running some process and I want to check if that process is running or not. One thing is you will see that in the terminal that is running. And if you want to check how many processors that is using, if it is using a GPU or not, those things you can check with top, U, and $user. This particular variable will always be there in your all the sessions. U is for user and you're giving the user. If you don't like this particular variable, you can also enter your user ID. For example, I can enter this one. And when I say that, it will list all the processes that are running currently in my name, with my account. I can say Control C to end that particular command, back to normal compute node. And if I want to check if I am using right now in a GPU, what is the GPU use? I can say GPU of NVIDIA SMI. This is the command provided by NVIDIA to you, which is again always available to all your systems, all the terminal systems. You hit enter and it will give you GPU uses. Right now you can see that GPU is not being used. And if I say, I think with L, I can say 2, probably, yes. So what -L2 does, it will print the GPU uses every 2 seconds. So if you don't want to run NVIDIA SMI, all over again and again, you can just say -L2 or 5, whatever. So it will continuously print the GPU users. Anyhow, Control C will end this. So why is that? Why is this command or this these commands are important? Why are these commands important? When you run a code, a simulation, or whatever you want to run. Say, for example, you have requested 16 cores and 2 GPUs, okay? And you have started your simulation. You want to make sure that you're using those 16 cores and 2 GPUs, because if you're not using, you're misutilizing your own budget. And that's not right for yourself and for HPC. If they come to know that you're asking for 16 cores and it's running on just single core, they might take some action, which I'm not saying, but that is what they say at least. And also when you're asking for 2 GPUs, this particular command, NVIDIA SMI, this particular will list down one more GPU. Like here you see, this is one list, Tesla K40, the GPU. There will be another basically right here in between these two, second GPU. And then, so whenever you run a job, make sure you know how many cores it is using and how many GPUs it is using. If it is using as much as intended, all well and good. Perfect. Next would be Neeraj. You need to turn on your microphone. Okay, perfect. I can hear you. Can you show one example of PBS? I rarely use actually PBS, so always use interactive systems.
Yeah, I will show. I have.
Perfect, thanks. Okay, I'm gonna end the screen sharing.
So this is my login node. So you can run the PBS script on login node as well.
Wait, I don't think we can see your screen.
Oh, sorry, I didn't share it yet. Just a minute. Is it visible
now
now?
we can see.
Just a minute. So you can see there are a couple of folders that I'm going into. So right now, so I'm taking example of case 4, right? So it is already having some simulation files that I'll delete right now. So you can see how I'm deleting it. They all are gone. So if the file name is like you have a very long file, okay, then you can put a star and you can take like .h5 or something, just this much of the text, okay, and like I did here, rm star dot dat dot h5, okay. So this was the common with the simulation files. So I got rid of all these files because in CFD you will have a lot of data files. And for PBS, we need a PBS script that I'll show you. Just give me a few minutes. Let me get rid of few files here. Yeah. So we have on for PBS using PBS script, we should have one bash file for it, and it depends on the software what you are using. So ANSYS Fluent uses a journal file as well to give the initialization, and that I'll show you just a minute. I think I need to log in into GUI.
No. You can in login node in
Gedit, I
gedit you
don't
can
think.
do that. No, it will work.
Let me check.
If it doesn't work, it's probably because the way you logged in.
Yeah, because I logged in. I didn't log in through -x. That may create a problem.
Then you can just exit and then log in with -x and y, and then yeah. And right now, I think you won't even. You know what? Just go ahead and try and see.
Yeah.
Yeah, it opens up. Oh no!
It opens, right? No, it doesn't.
Did you try gedit?
Not. Just a minute. Let me try it.
Go ahead, just try opening any file. Yeah, it opened up. See, just next to in your task.
It has opened. See, so journal file is like. So what is your case file name, and what is the initial data file you have? Because in ANSYS, what we give some input parameters, and it depends on the solver what case you are solving. Suppose that I'm solving a fluid flow problem. So it requires some initial velocity. What is the time step that you are giving? So this is the time step 0.01 second, and up to what number of iterations you want to run. So this is like 35 and 40. So when you multiply 0.01 with this, so it will be like 3500 seconds. Okay, so I'm running the simulation for 3500 seconds, around roughly around 1 hour, and this is 100 is like within one time step how many times you are iterating. So it's like 10 you just divide this 35,000 divided by 0.01 and then into 10. So this much of iteration it will run. So see, so this is very long simulation, and it's like software specific. This will change for other software. This is for ANSYS Fluent that I'm showing. So, but you will find similar kind of files, journal, and I'll show you the PBS file also.
Yeah, this is another method of submitting your job. One that we have seen with interactive session, loading the module and doing all those things. Neeraj is showing you submitting the job from login node without having to go through all that queues up
This
interactive method.
Yeah. So this is your PBS script. It will be almost similar, and these things will be similar, and rest of the things like module load and all that will change. So PBS is the name you can give. So I have given validation problem, and then P is your project and what the software you are using. I'm using ANSYS, and then here you will ask for the resources. So I will ask for 24 cores. Okay, let me check it with 8. And this is Fluent. So these are software specific. Here you'll give your account, email account, where you want the message to come in that your job has started. So this is for confirmation. So whenever you'll start with, if you don't want to give the email ID, that's okay. It won't appear in your email like your job has started or not. Then Fluent equal to 1. So there are some licensed softwares. So Fluent is one of them, and it requires license. So one is Fluent equal to 1. It means base license. It takes around 4 cores for the base license. So total I have asked for 8 CPUs. So 4 is gone here. Then HPC CPU will be 4 more. So 4 here, if equal to 1 is equal to 4, and 4 plus 4 is 8. So total N CPU is 8, and base license will use 4 cores, and HPC license will use 4 cores, to total 48. And I'm like, I should not go for more. Let's ask for just 10 minutes. Okay. And queue is like I'm using is standard queue. So there are like 3 queues. Sorry, 3 queues or 2 queues. Low, standard, and
There's a
high.
standard,
And high.
low is standard, high, and there is another test.
That I haven't used yet. So I have used only low and standard. So standard is like you'll get this very like easily, not easily, within very less time, not easily like high queue, but in low queue it will take longer time than standard. And standard you can use with your projects. If you have budget in your project, then you use standard, you'll get it, you'll get the resources very easily and within less time. Okay,
So yeah, these 3 different queues, standard, low, and high. The only difference between these 3 queues is that how quickly you're gonna get the compute resource. That's all the difference is. That's it.
Yeah. So and here PBS0 working directory. So wherever I am right now, there should be the bash file, and it will be fired from there. Okay, that's why these are the commands that will use for working directory. Okay, so this bash file you cannot fire it from any other directory, and sorry, any other folder, and your other files are in some different folder. So all the files should be in the same folder, and that is called working directory. Okay, so this export, this is the license file that you have to provide, because this is a licensed software. And then you have to load the module. So module load, that I think Krishna has already. So Parallel Studio. So if you are running parallel jobs, so for this software you have to load this Suit Intel and Parallel Studio. Okay, and then load the Fluent software. So apps Fluent, this is the version, and pre-compiled. Okay, so these 2 commands will load the software, and then job, and this is the execution command. Okay, so time. So this will depend on what software you are using. If suppose that you are using some other software like OpenFOAM, then it will change, and that will depend, like these commands you will easily find on this HPC. So they have given, I think, list of commands for softwares.
Yeah.
So from there you can get it easily. I'll show you once. Let me done with this. So NPI and tasks, all these things I've already provided here. It will take all those PBS and tasks. So whatever tasks, like 8 I have given. So 8 will be taken here, and this journal file will be executed, and MPI Intel it will use. So let us check. So for running using bash file, you need to first produce the executable. For that, DOS to Unix is a command. DOS to Unix, and then bash.sh. So for this bash file, one executable file is created, and I need to submit this bash.sh. So and
Perfect.
so yeah, it's done. So I want to check like whether it is running or not. So qstat -u, and then your Kerberos ID 218343. See, so it is showing SR. So it is about to run. So it has started running. See, okay. Or there is one more command that you can use to see whether if it is not running, then how much time it will take. So -ASW TU, I think capital T. SW.
Yeah.
TU. It will show you like, so right now it's running. So the job run at this time 6:21. So I think 6:22. If it was not running, then it would have like flagged like this. It will run on, suppose this is Tuesday, then it may run on Wednesday at this time. So it will show you, so that you can plan, or you can reduce your like whatever the like resources you're asking for, so that it should run within less time. Okay, so that's how you manage the resources on this HPC. So this is all about like PBS, running through PBS, and this is for ANSYS Fluent. And for other software, it will be like almost like similar. Few of the commands will change. Okay, but rest of the things will be similar. So I think through PBS it's done.
Let me show them PBS actually for other softwares.
Yeah, that's fine. So let me unshare this screen and then.
All right, can you guys see my screen?
Not yet.
Yes, sir.
Okay, perfect. So just gonna go to some new web browser, and you know what, I can just do this. Yeah, I'm gonna write HPC IITD and open up this website HPC IITD. At the top, you can see frequently asked questions. I think you should read it at least once, so you have way much better understanding of HPC. If you have a question, most likely it is already answered and it's here. You see somewhere here software and resources.
It's not
These
visible,
are the
Krishna. Screen is not visible.
Sir, it is visible to me. Yes, sir.
Oh, it's not visible to me.
Maybe you are on a different desktop, like within your laptop.
No.
Anyone else can confirm? Talk here. Is it visible?
Sir, it is visible.
Okay, perfect. So you can see that this is the list of softwares provided by CS department in IIT Delhi. And say, for example, if you're working with, I don't know, maybe lamps that often I use, I can click here, and you can see this one shows you how you can submit interactive job. And later on, if you see, this also shows you how you can submit a batch job, which is a PBS script basically. And this is a sample PBS script to submit a LAMPS job. Similarly, for other softwares, say for example, MATLAB, if you wanna submit a MATLAB job, they have a small PBS script here. You can see here. So for all these softwares, you will see sample scripts in this particular website. So for example, somebody wants to run a PyTorch script. For PyTorch, they don't have PBS script here. But yeah, these are the modules that they say are available. So maybe you can submit your interactive job then. With PBS also you can do, but very simplified. Let me show you. Probably. So yeah, these commands will be again same. You have to give the project name, the kind of queue. If you want to receive, if you want to be notified when your job starts or ends. These are for beginning, ending, and probably abort. Your number of resources that you want. So these things are common basically up to this point. This is common to all the softwares, no matter what kind of job you're submitting. Common everywhere. Kind of architecture again. Oh yeah, it shows for a CPU job, this is how you would do. For a GPU along with CPU, this is how you would do. Sample basically. The wall time, the software you use, this won't affect your calculations. You can write whatever you want. It is just for for the sake. And yeah, these things you better put it, because the terminal, the session from where you launch or submit your job, it will take when the PBS is basically a job scheduler. So you're submitting job, and PBS will basically, when the job starts running, when the compute resource is assigned to you, PBS will make sure that the job begins from that directory from where you have submitted the job or submitted that PBS script basically. So you better have these things. Module purge, you should write in your PBS script. You just want to make sure that there are no conflicting libraries in that particular session. And then, say for example, I want to run a LAMS simulation. For that, I must load a LAMS library. That is what I'm doing here. I have access to compute resources up to this point. I made sure that there is no conflicting library. Now I am loading the library that I need to run my input script, my simulation. So I loaded LAMS library. And then, yeah, I mean, this is going to vary for LAMS. Say you want to run parallelly or multiple number of CPUs, you can simply say MPI run. Again, that is something that will launch multiple instances of your LAMS. Let's not go into too much detail. So yeah, that is how basically you submit your job. Yeah, that's it. So for all the jobs, these things will be kind of same. In the end, you will purge your module and then load the particular module and run your job. And this will be different for all the softwares, the way they take input. For example, LAMS takes input with this particular command, -in. In ANSYS, we saw it was, I think, -I probably, not sure. And then
It was right. It
yeah,
was right. And you see here MPI run, there was time P or something. So this command line only will change. Rest of the things
yeah.
will be similar.
So this is like the ultimate command. All right, so yeah, that's basically about PBS script, all the softwares that are provided to you by HPC. And if you go down
One
in
thing
this
I
particular
want to
page,
add. So whatever like NCPUs and all, but why we are doing this? Because you have to use the resources judiciously. Okay. So for that, what we do, even if you are going for like project submission or something, you have to do some benchmarking study. That is very important so that the resources are not wasted. So you can check your software like at what number of cores and all it is performing best. Okay, so you can play around with this PBS files or interactive sessions, and you can run a couple of simulations with different combinations and see at what configuration it is performing best. So that I think those things will be when you move forward with the HPC, we will see, and we will ask you to do that as well. Okay, so yeah, Krishna, go ahead.
you know what? Give me like 10 minutes. I'll show you what Neeraj is saying actually. So anyways, if you see my screen, softwares page in HPC identity, if you scroll down, you will see all the modules that are available in HPC one by one. Is this the page? Yeah, you can see MATLAB ke kitne hain, PBS script sample, and all these packages that are there in HPC for you to load and work with. Another thing that I wanted to show you is tutorials and workshop. You click on tutorials and workshop, and this is where this PDF, the second one, I think it's the second one. The link is also given in that loop page, workspace page. This particular PDF will come in really handy. You have to go through this at least once or twice. See, if you go down, this is all about HPC. It shows you how you can log into HPC with -X. It says if you want to run graphical programs. Then it also tells you for Windows, you should use MobaXterm. Then it goes down. And yeah, it also gives you all these commands that are necessary to work in Linux. And then it goes here. You see, it says Haswell nodes have 250. There are total 250 nodes, 57 nodes. Each of them has 12 physical cores. RAM is here. So all this information, all that can, this information you get from this particular PDF basically. Home has 678 terabyte of storage. The Scratch has 3400 terabyte. And I should also mention that in HPC there are two kinds of storage. One is home, the other one is Scratch. Home is where, if you have your files in home, they're always safe. If you have your files in Scratch, HPC guys, they can delete it depending upon the availability of storage. If they run out of storage, HPC is gonna slow down.
But they will
send
you the
they will send
email
you mail
regarding this.
But they will not recommend you storing so much of data in Scratch. You can still store it as long as it's all good, but you will receive an email, and the moment you receive an email, you better back your files. If you don't, they will delete it. In your home, data is always safe. They will not delete it. They will not touch it. And even if they delete from Scratch, I think they back up those files actually before really deleting it. And if you want to check how much storage is available or you have used in your home or Scratch quota, you can check from these commands.
Also budget and all, how you check it.
Yes, coming to budget, when you are logged in HPC, this is the command. This is how you log in into. This is like I think they
Just
call
type
it some
this
manager.
command. Yeah, administrative.
Yeah. So you basically run this command and then you enter your password, and after that you can run these commands. Here, AMGR ls project will list all the projects that you are part of and from which you can use the budget. And then for a particular project, -n, and then project name, of course, which will be listed by this command, you can see how much money there is available in that particular project that you can utilize for your computations.
And that is departmental. So if you have non-departmental project, you follow the second command that is just below it. So I showed you one example, like P2 minus 653 Jati dot. So that was non-departmental project. We asked for this, and if I'm going for the chemical one, then I have to use the first the previous command. Okay, that is departmental. But
yeah, this is the first one for departmental. I think you will just enter probably for chemical. It's CHE,
chemical
I guess,
only. Yeah.
Or chemical.
Yeah, no,
it's chemical.
chemical.
Okay. And yeah, if you don't give these two, it turns out to be this one, and it won't give you. Say, for example, if I'm part
anything.
Yeah, it will give you 0 basically. So you have to have this -p and global so that it gives you exactly how much money you have in your project that you can utilize. Coming next, you can see all these commands are here. Module avail, to search for a module, to load a module, to see how many you have already loaded, to unload a part. This will unload only one module at a time. Purge will unload everything from your data active environment.
This is all about PBs. You just read it, you'll get
to know, yeah. And yeah, what each flag means in PBS script, you can read from here. There are many samples.
Interactive.
How to request interactive sessions. Yeah, Neeraj, when Neeraj was running, his status of calculation was R, which means running. You can see what each of those letters mean. Of course, NVIDIA SMI L1, like you see, you want to see your GPU uses every 1 second. You want to see all your CPU uses here, top U user.
This PPT is quite useful when you are dealing with HPC.
Really useful. Yeah, really useful. So make sure links are given in this particular workspace.
Yeah, it's there.
So these guys have access to it. Okay, let me show you what Neeraj was saying about using things.
Just show the file, okay? Because this thing right now at this stage, they won't be able to understand that much. Just show how you show the file that you have done in benchmark.
Which, yeah. Oh, okay. You know what? Let me open up somebody's benchmarking file.
Yeah,
I may have mine also.
That is really very important because.
Yeah, yesterday me and Tokir we spent quite a lot of time understanding that in labs. So look at this one. This guy has benchmarked his calculations, and let me tell you, this will be different for each job you submit, depending upon the system. I mean, at least that is what is for me in my case. So every time you submit a job, it is recommended that you run that particular job for a smaller time, say for 5 minutes or 10 minutes, and you see the speed. So this guy has benchmarked using 1 GPU combined with 10 CPUs, and he says that the performance was 80 nanoseconds per day. This was molecular dynamics simulation job. Again, 1 GPU, he increases the cores, doubles the core, and you can see when he doubles the cores, the performance is increased, but not doubled. 40 cores, very slight increase. So you see, it's way much better to just use 10 cores or maybe 20 than 40. Even though you see some performance enhancement, it is just not worth your money that you're paying for that extra 30 or 20 cores. So yeah, that's basically it. And whenever you're running your code, see if you can launch parallel the same code. You can run in multiple cores, and if it is possible to run in GPU, if it is possible, go ahead and try. Those things will save you money for sure. That was basically benchmarking study. So yeah, all these things are done. Anyone has any question? Neeraj, anything you want to add?
I think this is pretty much for the time being. But later on, we can have another session if we get some confusion or something related to HPC. We will always keep on like asking on this group. But for the time being, I think this is pretty much. They need to practice it. So whatever Linux command that we have shown you, just practice it for once, okay? And also see like how to get used to with this module list. Just look into it, like what are the modules that are there. Look for the software that you will be working on. Suppose that someone is working on molecular dynamics, so on internet you search for those softwares and try to look into the HPC whether it is available or there or not. And if people are using machine learning and all, so look into like Python, what are the other modules that you require, and look into that module list whether it is available or not. They're like PyTorch and all you require in machine learning, and TensorFlow also. So look into those things, explore this HPC in your free time, and this is how we learn, and just practice. Okay, so I think this is pretty much. And yeah, anything from you guys you want to ask, then go ahead, please.
Sir, thank you, sir. It was pretty clear, but we'll get more clarity when we try it hands-on.
Yeah, when you will run. That's what I'm saying. Just whatever we have shown you right now, just practice it before the running of the job. Okay. Before that, those commands, just try for it. And the people who are having the access, they can check with the CPUs and all. But you will require the project name. So for the timing, you can use the project name as chemical. And see, ask for very less time, like 1 or 2 minutes, just for checking. Okay, wall time.
Yeah.
And see, just practice it. You'll get when you'll use it, you'll get. You'll.
You know what?
Yeah.
Even if you don't have compute resource, like you, it is not recommended to run over 1 minute. Like any job that takes more than 1 minute, don't run it.
Yeah, it's very dangerous.
It's a warning from HPC to everyone. Because login node is for everyone. Even when you are not paying money, you are using login node, and when you start running compute intensive jobs, it kind of like creates inconvenience for others, so they don't want it to happen. But just go into HPC, LS, PWD, CD, all those things, make directory, do that. Write a simple Python script which will add two numbers, subtract two numbers, and run it directly on login node. It's totally fine. I mean, how much time does it take really? A few seconds.
Yeah, and one more thing, like you guys can provide the feedback also, like how can we improve this learning in the next presentation, whatever we will have. And the second thing I want to say, so you have a 25th presentation, meeting, okay, for all of you on 25th of December, right? Are you aware of that? No? I have already mentioned in the group. You know, na 25th. Are you there, guys?
Akshay बोल रहा है, yes.
Yes. So
Anas भी बोल रहा
so,
है.
Yes. But
Nana Jan will present on that day. So you guys also update whatever you have learned in the whole week. You can tell about this HPC also. You have practiced it or not? Yeah, these things you can tell in the presentation, because ma'am will be there and she will be like ask. Yeah, she may ask, and also take how much time you guys have for this semester? 15 days more, and then
yes, so then the next semester.
next semester you will be doing the projects, na? Yeah, so like 15 days you will be free of classes, so make use of this time in learning these things, and later on everything will be like simulation based, and your analytical things will come up. So right now you just practice and learn the software and the other tools that will reduce your time. Otherwise, like when your classes will start, then it will take time to learn these things. Okay, make use of this time to learn the tools, and we are here to help you wherever you will stuck. Just write us on the group. We will get back to your queries. Okay. So I think this is pretty much from my side. Krishna, if you want to say something, go ahead.
नहीं ठीक है. This was good enough. I think we can conclude today's tutorial, if that was tutorial.
Yeah. So thank you very much for joining us, and recordings. I think someone was recording it, right? Tokir, you were recording.
All of us have available.
Yeah, that's great. So you can also look into this recording whenever you have any doubt. Okay.
Yeah.
Okay,
right.
then.
Yes, sir.
Cheers,
Thank
sir.
you.
Bye bye.
Bye bye.
Okay, thank you, sir. Okay, bye.
Thank you.